Okay, so like yesterday, we're going to be working with three variable systems today. But unlike yesterday, where it was easier to use elimination, substitution is the easiest method to use. And here's why. Remember when we worked with two variables and you knew that substitution was the easiest to use when you had 2x plus 3y equals 1 and y equals 2x minus 1 because one thing was in standard form and one thing was in slope-intercept form? Well, in this problem right here, you have one thing in standard form and two things in slope-intercept form. So because that's the case, it's easiest to use substitution. So that's what we're going to do. We're going to start by substituting this last thing in, or the x by itself, into both the other equations, so we have no more x's. Let's see how that works. So I'm going to put this last x into here and into here. So I would have negative 5y minus z plus 23 minus y minus 3z equals negative 9. Since I took that and just plugged it into the top one, then I'm going to take the x and plug it into z. So I would have z equals negative 3 times 5y minus z plus 23 minus y, not minus y, started going into the last equation, minus 1. So let me just erase that really quick. Minus 1. And so those are the two equations that I get, and see how I have no x's left? So now we'll start by making this equation a little bit more simple, and this other equation a little bit more simple. So taking that top equation, I'm going to make it more simple by taking the negative sign and distributing it to all the things on the inside, giving me negative 5y plus z minus 23 minus y minus 3z equals negative 9. Now I'm going to combine like terms, so I'm going to combine the negative 6y with the negative 5y. I'm going to combine the z with the negative 3z. I'm going to add this 23 over. So negative 5y and negative y will give me negative 6y. Z and negative 3z will give me negative 2z. And negative 9 and 23 will give me 14. And so now I've just simplified the top equation into that right there. So we'll go back and we'll simplify that bottom equation now. So that bottom equation was z equals negative 3 times 5y minus z plus 23 minus 1. So again, to simplify this, I'm going to distribute that negative 3, which will give me negative 15y plus 3z minus 69 minus 1. So again, we can start trying to combine like terms. I can minus the 3z over, and I can combine this back here. So I'll have negative 2z equals negative 15y minus 7. Now, for this, I could leave it like this, but I do like how that z was all by itself, so I'll just divide this negative 2 and get my final equation to be z equals 13.5, or not 13.5, but 7.5. 7.5y plus 35. So now I have the bottom equation simplified and the top equation simplified. And we'll look at those two things and decide what we can do with them. Now as we can see, this kind of looks like our normal substitution problems. I have one thing in standard form, and I have one thing in slope-intercept form. So let's take this z and plug it into here, and see if we can get this down to one variable. So I'll have negative 6y minus 2 times 7.5y plus 35 equals 14. Now when we simplify this, I'll have negative 6y minus 15y minus 70 equals 14. I'll add the 70 over. I'll combine these two things, which will give me negative 21y equals 84, or that y equals negative 4. So now that I know that y equals negative 4, I can plug that into here and figure out what z equals, and then plug that z into the final x equation and find what that all equals. So I'm going to write that on a new page, and we'll see how that works. So from here we know that z equals 7.5y, but instead of writing y, since we found that was negative 4, I'm going to plug that in, plus 35. So z will equal negative 30 plus 35, or z will equal 5. And if we go back to the very original equation, where we plug everything in for, I still need to find x, so I know that x equals 5y minus z plus 23, but we found that x equals 5. Well, instead of writing y, I'll put negative 4 in there, and instead of putting z, I'll put 5, which we just found, plus 23. And if you combined all this stuff, you should get that x equals negative 2. So we've gone through and we found all three of them. We found that x equals negative 2, z equals 5, and y equals negative 4. Now this is a time-consuming process, but it's doable. All you need to remember is go back to what we've done, which is you just start plugging in at each stage. You just start plugging in all the different variables into the previous equation. So start with the last one, plug it into the middle, plug it into the middle, start simplifying, and then keep plugging until you find a final answer. Hopefully this helps. This is also the first question on your guys' 5-question quiz. If you have any other questions, please do not be afraid to email me or send me a message in Canvas. Thanks, guys.